Welcome to Creative World. In this video, we will solve Chapter 3 exercise problem number 3.10. While solving this problem, we will be using Kirchoff's current law. According to this law, a cumulative current on a node inside an electrical network is always equal to 0. Sum of all entering currents on a node is always equal to sum of all leaving currents from that node. We also will be using Ohm's law. According to this law, voltage across any resistance R is the product of current through it and the value of resistance itself. Now move towards the problem. Exercise problem number 3.10. Use nodal analysis to find current I0 in given below figure. This is the circuit diagram of given problem. Inside this network, we have to find the value of current through this 6 kilo ohm resistance branch labeled as I0. So without wasting time, let's proceed towards the solution of the network. We know that in order to apply nodal analysis on any network, we have to follow some steps. First step includes finding out the maximum number of node voltage equations that can be retrieved from that network. Using this equation, we can find out that figure. In this equation, n represents number of nodes exist in network. In our case, 3 number of nodes exist in this network. So 3 minus 1 will be equal to 2. So we can find out maximum 2 node voltage equations from this network. In second step, we have to label all unknown non-reference node voltage. So this node voltage will be considered as V1 and this node voltage will be considered as V2, while this node will be considered as reference or ground node. In third step, we have to assume all unknown branch currents along with their directions. Now we will apply Kirchoff's current law on these two non-reference nodes one by one to find out their node voltage equations. We will start from this node. On this node, one current is entering, that is 1 milliampere, while 3 currents are leaving, I1, 2 milliampere and I3. So Kirchoff's current law equation for this particular node will be 1 milliampere minus I1 minus I3 and minus 2 milliampere. All of these are equal to 0. Here entering current is taken with positive sign while leaving currents are taken with negative sign. In next step, we have to replace these two currents with their respective equations and subtract 1 milliampere from 2 milliampere. Current I1 will be equal to V1 minus V2 divided by 2 kilo ohm. This current is flowing between two non-reference nodes, so potential difference of these two node voltage will be appearing across this 2 kilo ohm resistance. And the potential difference of these two node voltages divided by the value of resistance will be equal to the current through this branch. Now the direction of current I1 is from node 1 to node 2. Which is indicating that V1 is higher than V2. So the potential difference across this resistance will be taken as V2 will be subtracted from higher voltage V1. And current I1 equation will be V1 minus V2 divided by 2 kilo ohm. Current I3 will be equal to V1 divided by 8 kilo ohm. Now in order to omit all denominator values, we will multiply this equation on both sides with 8 kilo ohm. Product of 8 kilo ohm and 2 kilo ohm in denominator will cancel out with each other. Only 4 will be left and that 4 will multiply with V1 minus V2. Here product of 8 kilo ohm and 8 kilo ohm in denominator will cancel out with each other. Only V1 will left. And here the product of 8 kilo ohm and 1 milliampere will result 8 volt. Now place this constant value on the other hand side of equal and open these brackets. The equation will become minus 4V1 plus 4V2 minus V1 equal to 8 volt. Add values having same variables together. The equation will become minus 5V1 plus 4V2 equal to 8 volt. We cannot further solve this equation, so we will leave it for now and label it as equation A It is the first node voltage equation of this network. Now we will apply Kirchoff's current law on this node. On this node, two currents are entering, I1 and 2 mA, while two currents are leaving, I2 and I0. Entering currents are taken with positive sign and leaving currents are taken with negative sign. Now we have to replace these three currents with their respective equations. Current I1 is equal to V1 minus V2 divided by 2 kilo ohm as we have calculated in previous step. Current I0 will be equal to V2 divided by 6 kilo ohm. Similarly, current I2 will be equal to V2 divided by 3 kilo ohm. Now again we will multiply this equation on both sides with 6 kilo ohm in order to omit all denominator values. Product of 6 kilo ohm and 2 milliampere will result 12 volt. Here product of 6 kilo ohm will cancel out with 2 kilo ohm in denominator. Only 3 will left and that 3 will be multiplied with V1 minus V2. Here product of 6 kilo ohm will cancel out with 6 kilo ohm in denominator, only V2 will left. And here product of 6 kilo ohm will cancel out with 3 kilo ohm in denominator, only 2 will left and that 2 will be multiplied with V2, it will become 2V2. Now open these brackets and place this constant value on the other hand side of equal. The equation will become 3V1 minus 3V2 minus V2 minus 2V2 equal to minus 12 volt. Add values having same variables together. It will become 3V1 minus 6V2 equal to minus 12 volt. We cannot further solve this equation, so leave it for now and label it as equation B. It is the second node voltage equation of this network. Up to this point, we have retrieved two node voltage equations from this network. Now we will try to solve these two equations to find out the value of voltage V2. If we succeed to calculate the value of voltage V2, we will be able to calculate current through this branch, that is equal to V2 divided by 6 kilo ohm. And it is the required parameter asked in this scenario. So first of all, we will try to find out the value of voltage V2. For that purpose, we will multiply this equation A with 3. The equation will become minus 15V1 plus 12V2 equal to 24 volt. And we'll multiply equation B with 5. The equation will become 15V1 minus 30V2 equal to minus 60 volt. Now add these equations together. Minus 15V1 and plus 15V1 will cancel out with each other. 12 minus 30V2 minus 30V2 plus 12V2 will become minus 18V2. On the other hand side of equal, 24 minus 60 volt will result minus 36 volt. Now in order to find out the value of voltage V2, divide on both sides with minus 18. V2 will be equal to 2 volt. After calculating the value of V2, we are able to calculate current I0, that will be equal to V2 divided by 6 kilo ohm. Replace V2 with its value. I0 will be equal to 2 volt divided by 6 kilo ohm. Divide 2 volt with 6 kilo ohm. Value of current I0 will become 0.33 milliampere. So the value of current I0 through this branch in this network is equal to 0.33 milliampere. So this was exercise problem number 3.10. Thank you. See you again in next video.